let me know when to start. We're good to go? Okay. Okay. Can you hear me? There? Okay, thanks. Well, let's start. We're talking about forensics and anti-forensics on SAP systems. First of all, let me ask you something. How many of you are familiar with SAP systems, are running SAP systems, or doing pen tests against SAP systems? Okay. Well, most of you are gonna learn something new there. Well, a little bit of a disclaimer about the namings and all the brands. So, who am I and who do I work for? First of all, I'm Juan Perez Etchegoyen. That's Juan Pablo Perez Etchegoyen. That's kind of a long name, so for the sake of easiness, you can call me JP. It's much easier. But yeah, that's my name. I work on Apsys. We specialize on SAP security and actually on business critical applications. We also cover Oracle applications as well, but we are very focused on SAP applications. We do pen tests, trainings, presentations, develop software, all that around SAP systems, and that's why we are usually presenting on security conferences such as this one. This is my first time in DerbyCon, so it's as far as what I could see, it's a great conference. I really like it. And my background is coming from pen testing and doing research. Also reported several vulnerabilities to SAP as well, because we are doing research mainly focused on SAP. So this is what we are going to talk about. Sorry, I apologize for my English. If there's something that's not clear for you, just raise your hand or let me know so I can go over it again. We're going to talk about SAP systems very briefly for all of you that are not familiar with it. Then we're going to talk about the forensics techniques. So which are the features that SAP is actually providing us in order to register activity on the systems and to be able to actually spot attacks to those systems. And then some anti-forensics techniques. I have some videos. I'm not able to run an SAP system here on my laptop, but I have some videos of some attacks that are actually abusing of these techniques, of these features, in order to hide the source of the attack or completely hide an attack to an SAP system. And then draw some conclusions. So by no means this is a full anti-forensics guide, so we are not going to cover all the techniques. We are just going to shoot some examples and introduce you to this topic, which is very, very interesting. So what is SAP? SAP is the biggest software vendor or provider in terms of business applications. And we are talking about applications that are running the most critical business processes. We are talking about ERP, CRM, maybe those terms are more familiar for you, BI, business intelligence, business warehouse, GRC, solution manager. All those are applications that are running on top of SAP systems. So which makes this system so different from other systems or other applications is that these are the applications that are being used by the biggest companies in the world to run their business processes. So we are talking about Fortune 10, Fortune 100, Fortune 500 customers, governmental entities. All these kind of the biggest companies in the world are running SAP systems, and that's where our focus is. And some examples of the processes for you to get an idea of this, the type of systems that we are talking about. It's sales, procurement, logistics, payroll, treasure. All the HR information, all the processes are interconnected. Usually when you get into an SAP customer, it's not like they have an isolated system. They have many landscapes all interconnected, so it's a very complex scenario. And we also, as I said before, we do penetration tests on SAP systems. So we go to customers, they provide us with an IP address or a network. We do discovery of the SAP systems, and then after X number of days, we came up with a report showing the different vulnerabilities. And these are the statistics that we got from doing these pen tests. It might sound incredible, but this is how most of the SAP systems are right now in current companies, right? And this is what we saw during the last years. We end up usually having full system compromise on the SAP systems. And full system compromise, by that I don't mean having an ID0 or root account, right? We're not looking for the best exploit to the latest exploit to run against the system. We are talking about having full SAP system access. So database access, having access to all the SAP tables, user master table, all the tables in the ERP systems, bank account numbers, credit cards information, formulas, HR information. So all that information is stored in the SAP systems. That's why it makes this system so critical. We are talking about, as I said before, we are not talking about just triggering an exploit, right? We are talking about sabotage, espionage, and fraud attacks. Because if an attacker is actually targeting the SAP systems, he's not gonna go after being the best hacker of the world. He's going to go after the information that is there to do an espionage attack. If we are talking about a competitor, he will try to do a sabotage attack. And I mean, these systems are mission critical. So you can imagine that an hour of these systems being stopped, that would mean literally will mean millions of dollars of losses to the company. So it's we're talking about very critical systems. And also financial fraud attacks. If within the system there is a payroll information, if we have HR information, if we have bank account numbers, if we have credit cards information, all that information could be tampered with, and then an attacker would be able to try to do a financial fraud attack. So that's possible because of the criticality of the information there. But, well, we have been doing pen tests on SAP systems since a long time ago. We faced SAP customers, and usually what we get is our SAP systems have never been hacked. We are okay. Everything runs perfectly. We have no problems. So in order to do that, in order to like really know and understand that there was never a breach to the system was never compromised, you need to have several things in place. Security audit log, you need to have the traces enabled, you need to have all the information sent to an external place and then analyzed, continuously monitored to be able to spot an attack. Well, that's not the situation. We usually find that systems are configured typically by default, so there is not so much security on top of the default implementation, and that means that usually you don't have any auditing information, and you lack of information to be able to identify an attack. So how can you actually know if the system was attacked if you don't have the information to say it? So that's a typical situation. And in terms of forensics, SAP forensics, let me move forward. This is the anatomy of the attack. The good thing is that SAP systems are shipped out of the box with a lot of features in terms of doing forensics, right? So we have security audit log, we have many other features that we will talk about later, but these are shipped out of the box, so you don't have to install anything, you don't have to implement anything. You just need to properly size the system and configure the system. That's good, but it's something that is not so common to see in real-life implementations. So this is kind of the second part of a talk that we held together with ONAPSICIO in Troopers 2013. That's in Germany. So I encourage you to take a look at the full presentation. It's on our website. On that presentation, we go over all the different features provided by SAP, so showing the pros and cons of each one and which are the limitations. So that's something we need to understand. So this is the anatomy. Usually, the attacker gets access to the system by exploiting a vulnerability. Those vulnerabilities are usually misconfigurations or insecure settings or missing patches on the technical layer, on the NetWeaver layer of SAP. Then the attacker moves up into the SAP layer, to the business layer, to the ERP, CRM, all those business functions that are supported by the NetWeaver layer, And then if the attacker is skilled enough, he would try to hide his trails. He would do some attacks in order to actually avoid being discovered. So yeah, this is, I encourage you to go to the other presentation. That's more in the forensics part. And in the forensics part, here what you have is a list of all the different features. Security audit log, we are going to see some demos of the security audit log and which are the limitations and how to actually play with the security audit log in order to avoid being detected. That's kind of the most important feature, right? So if this is the security, the audit log in the system. So if you want to spot some user doing a brute force, if you want to spot some user trying to execute something he's not authorized to, that's the feature you need to have enabled. It's not enabled by default. The problem is that this is very resource intensive, right? So it's when you enable it, depending on the number of users, and we are talking about systems running with 1,000, 2,000, 5,000 users, and many concurrent users at the same time, generating, executing transactions and executing business functions. So it's a lot of activity. So if you enable this, it's going to have a huge impact on the system. However, it's a matter of proper sizing, right? So you need to have it. Then all the rest of the logs are kind of technical logs, but many of the attacks that are going through the NetWeaver layer are not actually saved in the security audit log. You need to have all the rest of the logs enabled in order to actually identify a complex attack. Because detecting a brute force attempt in the system, that's easy, and the security audit log can help you with that. But the rest of the attacks, the more complex attacks, that's something different. So yeah, system logs, developer logs, gateway logs. There are many attacks going through the gateway. That's a very important component of the SAP system. SAP router, web dispatcher, table change logging. So there are many features that we need to be aware of, because otherwise we are kind of missing a lot. So let's see the first attack. Security audit log. This is the most important feature that, as I told you, in terms of auditing, right? But what happens is that the security audit log is something that is embedded into the SAP system, and it's basically saving each event on the file system in a file on each application server. So an SAP system is usually composed, the productive system is usually composed out of 2, 5, 10, 15 application servers. Each one is going to hold the files with the audit trail. The problem is that in order for that to be shown to a user, there is a template that is coming from the database, and that's being used in order to be able to see the actual messages. So what we discovered is that a user having a specific authorization, which is the T-code authorization, nothing more than that, would be able to actually connect to the system, delete the template, and all the messages will be gone from the system. So even though the event was registered on the file system, it's not ever going to be shown to a user. So it's kind of was never there. So there was a sub-security note fixing this, enforcing the permissions, and the impact is, it's a complete anonymity of any attack, because being able to delete a specific message, that specific event is going to disappear in the whole SAP system, regardless of who is the user that is triggering that event, which is the source, what's the application server. The event is gone. So let's see a video of this. So for those of you who are not familiar with SAP systems, this is kind of the client, the SAP client, right? So the client is connecting to the system. We are actually creating a user with that specific authorization that allows the user to delete the message. So this is very typical for admins, connecting to the user, executing SU01, and assigning that transaction, that T code. That's the only authorization object that was assigned to the user. On this part, we are showing that, and then we go to the transaction SM20 to actually see the security audit log events, and we can see that there are some events here, these ones, and you can see user logged because of a password. We're going back there. Well, there was several events, and there was a specific event that was only once there. That's because we triggered this event only once to be able to actually delete the event, so the user connected to the transaction that he's authorized, SE92, deletes the message, this template, and then after that we will see, well, that's all the process of deleting. He just clicks on delete, creates a transport order, that there's a process. That's the place that, yeah, that's the event that you're not gonna see anymore. User seed block logged in client 300. So if we move forward, because I know we have limited time, actually all this time is because we need to wait for a system restart, right? Because as this is in the database itself, we are modifying a table in the database, we need to wait for the system to be restarted. But just when the system was restarted, the user is connecting again, going to transaction SM20 to see the events, and the response is going to be a little bit different. So he's filtering the query, and we will see that in the middle there is no event with user seed block locked because of a password attempt, something like that. So what happened is that every event of that specific template that he deleted is gonna be gone from the system. So that's the impact, right? It's a huge impact because you're not gonna be able to see any more of these events. So moving forward, we saw the demo, and countermeasures is implement that subsecurity node and also restrict the authorization as developed. We need to be aware of the authorizations on the system, because a user being authorized to do anything, such as a SAP user, will be able to delete any message, will be able to access any information. So in the end, authorizations is a big issue in SAP systems, so we need to properly take care of that. Second attack, hide source of attack. And this is kind of very, very interesting. Security audit log has a unique field for the source of the event, right? So we might see in some other log or correlation products that you have IP and hostname or other fields, right? Well, security audit log only has source field. So what is actually being saved in that field? Well, it depends. The application server is doing a best effort, so he's putting the terminal name, and if there is no way to put the terminal name, he's putting the IP address. So we don't know if this is actually a terminal name or an IP address. The application server is going to decide. And the terminal name is something that we provide as a client, right? So when the client is connecting, he's saying, hey, I'm this client. So we can control that piece of information. So what happens is that depending on one profile parameter that is a configuration, the profile parameter is the configuration of the application server, is how the system is going to behave. Because if the profile parameter is not enabled, the terminal name is going to be there, or it could be the IP address. We don't have control of that. So what we can do is actually spoof the terminal name, right? So when we connect to the system, this is again the SAP client, POC user, POC user, connecting. We have invalid logon attempts, and if we go to SAP system, we will see that these invalid logon attempts were recorded with the terminal name. So that's okay. That's regular or normal behavior. So when we go to transaction SM20, we go to see the logon attempt, failed, POC user, term 1, this is terminal 1, that's okay. But what happens is that if we execute a specific Python script, for example, tampering the terminal name, we can say, hey, I'm this terminal name, but instead of putting a terminal name, we can put an IP address. And there is no way for someone analyzing the logs to actually decide whether this is a terminal name or an IP address. And we can fake the IP address, the source IP address, saying, hey, we are any IP address. And that's basically tampering with the source of all the events. So here, if you can see, after the execution of the script, in the terminal name, in the field, you will see not term 1, but the IP address. And that's not the real IP address. That's the IP address that we provided as a parameter. We can configure any IP address. So we are basically tampering with the source. So moving forward, the impact of this is complete anonymity of the attack. We saw the demo. So countermeasures, yeah, enable this profile parameter. It's not enabled by default, but we need to have this enabled. We need to make sure that the proper information is being logged. And there is a sub-security note also with recommendations in this sense, so I encourage you to take a look at that note. And the third attack, I'm not going to be able to show you the video, but I'm going to actually tell you what happens. Is security audit log is actually the most important feature, right? And there are many parameters that you need to configure in order to drive the behavior. But what happens is that if the security audit log is full, like if it reaches the limit in terms of the file size, it will stop logging. So anything coming after that won't be registered. So nothing will happen. It's like you can run any attack, the attacker will try to connect to a system, will execute anything, and nothing will be registered. So even though that might sound bad, which is bad, but it's kind of a definition, right? That's what we need to know, because what's important here is that what would you do if you reach a limit of an audit log, something that should be an audit trail, and you need to have you need to be able to trust on that. You cannot rotate, right? Because you are going to be deleting all the events. So the only thing you can do is stop logging. And the problem is on the user side. So we need to have we need to properly size the system in terms of users, in terms of application servers, to avoid these kind of things. Because otherwise, anyone just knowing what is being logged on the system could trigger that event just to fool the log, and that's it. We don't have any other security audit log. Again, the impact is complete anonymity, and here what we need to be aware of is this is not a matter of configuration, this is not a matter of patching, this is a matter of sizing. This is something that we need to be aware of before the implementation, before go live, and put configure the security audit log with the maximum that we expect to have, actually more than that, and have enough space in the disk to be able to store all these files. So this is for you to keep as a reference, SAP logs and traces. What's important here is we need to be aware of the limitations of each one of these. So for example, change documents, user authorization change documents, table change logging, those are all tables. However, the first one, security audit log, developer traces, all those are files on the file system. So we need to properly size the system in order to avoid having this reach the limit and losing events in between. So this is just for you as a reference. So let's draw some conclusions and recommendations. Enable logging and tracing mechanisms. Some of them are enabled by default. However, many of these features are not and are not properly sized. So we need to be aware of this. We need to get to the system, analyze what's the activity on the system, properly configure the parameters to avoid having something like the security audit log reaching the limit. Enable technical logs too. Correlation is very important here because many attacks are not only in the security audit log but just understanding how different things are working. Send the logs to a centralized facility whenever it's possible. Well, it's key to review the logs, right? So it makes no sense to have everything in place if there's no a person like analyzing the logs and spotting attacks. Implement SAP security nodes. Also patch the systems, configure the systems up properly, implement SAP security not only in the business layer but also in the technical layer. Profile parameters, also the configuration is something we need to restrict. The sizing, I already talked about that, but we need to be aware of the systems, what's the activity, we need to properly size all these features. It's important to understand the limitations and features of all these mechanisms, because otherwise we can be having attacks targeting our SAP systems being unnoticed. Equivalent privilege is equivalent to SAP all means full system compromise, means that you cannot rely on any log. So in the end, you not only need to properly save all the logs, but also you need to properly set the authorizations, because one user with insecure authorizations could be authorized to delete the logs or do anything within the SAP system. So if it's already difficult to know whether the SAP platform was compromised, not having the logs makes this even impossible. So that's I think this is kind of a conclusion. References, subnodes, some documents, thanks to the NAPSIS team, who's also always helping discovering vulnerabilities and also publishing about this. The other presentation, and if you have any questions, it's outside, right? But other than that, thank you all.